Hi viewers, this is Mrs. R. PADMAPRIYA from St.Joseph College of Arts and Science, Cuddalore, working as an assistant professor in PG and Research Department of Mathematics. Discuss about the vector differentiation. In that, we are going to discuss the divergence and curl. Let us see the definition for solenoidal. A vector function f is said to be solenoidal on divergence free. That means if divergence f is equal to 0, then it is called solenoidal. Before seeing that solenoidal definition, we have to know the definition for divergence. Then only we can find the solenoidal. The divergence definition is if V is equal to V1 I vector plus V2 j vector plus V3 k vector is defined and differentiable at each point x, y, z. The divergence of V is defined as divergence V is equal to del dot V. We know that the del value is nothing but I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z. When find the dot product with V, that is V1 I vector plus V2 j vector plus V3 k vector, we will be getting dou V1 by dou x. I dot I vector value is 1. So we will be getting dou V1 by dou x plus dou V2 by dou y. Here j dot j is 1 plus dou V3 by dou z. Here k vector dot k vector is equal to 1. So the formula for del dot V is dou V1 by dou x plus dou V2 by dou y plus dou V3 by dou z. We have to substitute the value of V1, V2 and V3. Differentiate V1 with respect to x, differentiate V2 with respect to y and differentiate V3 with respect to z. When finding the value of del dot V, if we get the answer as 0, then it is called the solenoidal vector. Let us see one example. Verify that f is equal to, the f value is given as 2x squared z I vector minus x y square z j vector minus 3y z square k vector is solenoidal or not. We have to check whether it is a solenoidal or not. To check the solenoidal, we have to find the del dot v vector. So we know that the formula for del dot v. Here the vector is given as f. So we write del dot f. It is nothing but dou v1 by dou x plus dou v2 by dou y plus dou v3 by dou z. Substitute the value of v1. v1 is nothing but the I vector coefficients. 2x squared z plus dou by dou y into v2. v2 value is nothing but minus x y squared z, j vector values, plus dou by dou z into v3. v3 is nothing but minus 3y z square, k vector values. Now differentiate 2x square z with respect to x. When we differentiate x square, we will be getting 4x z. 4x z. Next, differentiate y with respect to, minus x y square z with respect to y. When we differentiate y square, we will be getting minus 2xy z. Next, minus 3y z square with respect to z. Differentiate that. When we differentiate z square, we will be getting minus 6yz. So all the three values are different values. So we are not able to cancel these values. So it is not equal to 0. So del dot f vector is not equal to 0. So f is not solenoidal. Let us see another one interesting definition, that is irrotational. Irrotational is based upon the curl definition. A vector function f is said to be irrotational on curl free if curl f vector is equal to 0. Before going to the irrotational definition, we must know the curl definition. The curl is nothing but if v is equal to v1 I vector plus v2 j vector plus v3 k vector is defined and differentiable at each point x, y, z, the curl of v is defined as curl v is equal to del cross v. In divergence, we came over del dot v. Here del cross v. Curl means del cross v. So del cross v is nothing but the determinant of I vector j k. The second row dou by dou x, dou by dou y, dou by dou z. The third row write the values of v1, v2 and v3. So in the problem we have to substitute the third row v1, v2, v3 value and expand the determinant. If we get the answer as 0, then it is called irrotational. Let us see one example. So verify f is equal to I vector into 6xy plus z square plus j vector into 3x square plus z plus k vector into 3xz square minus y is irrotational or not. Let us see the solution. We know that for the irrotational we have to prove del cross f vector is equal to 0. Let us first find del cross f. The first row, the determinant of the first row is I vector, j vector, k vector. The second row is dou by dou x, dou by dou y, dou by dou z. In the third row, we write the v1, v2, v3 values. That is, I vector values are 6xy plus z square, j vector values are 3x square plus z, and k vector values are 3x z square minus y. So that is equal to, let us expand this determinant. I vector into means we have to skip the first row and first column, multiply though this term dou x z square by dou y minus dou by dou z into 3x square plus z. So in this way we have to multiply. The second term minus j vector, you skip this column, then multiply dou by dou x with 3x z square minus y minus dou by dou z into 6xy plus z square. Next is plus k vector into, k vector means you have to skip this column and this row, multiply this term dou by dou x into 3x square plus z minus dou by dou y into 6xy plus z square. See this. So we expand the determinant form. Now differentiate the terms with respect to x, y and z. The first term, here we have to differentiate with respect to y. So when we differentiate with respect to y, the first term there is no y term. So put 0 minus 1. The second term is with respect to z means 3x square, there is no z, so put 0. We differentiate z, we will be getting 1. Minus 1 plus 1 will become 0. Minus j term, come to minus j term. With respect to x means 3x square minus 0. Next term is with respect to z means 0 plus 0 plus, that is z cube, not z square, z cube 3x square plus k vector into 3x square plus z. And we differentiate with respect to x means we will be getting 6x minus with respect to y means that also 6x minus 6x. So all the terms get cancelled. So the answer is 0. So del cross f vector is 0. So f is irrotational. Thank you viewers.